4-6, arithmetic sequences. So starting off, a sequence is an ordered list of numbers, right? A sequence is just an ordered list. It's a list of numbers. Each number in a sequence is called a term. Each term, sometimes called a sub n, so that little n down there, that's talking about what term it is, right? So like the first, second, third term, and you say it a sub n, right? If it was, that's not what happens, right? A sub 5, that's talking about the fifth term. The 5 is in a subscript, right? We have exponents, that's like x to the fifth, and then we have subscripts, which are like x sub 5, right? Little 5. Has a specific position in, right? So we're talking about like the fifth place in my example in the sequence. So this is the like 5, 10, 15, 20, 25, and this is supposed to be a dot, 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 and then a sub n, and then dot, dot, dot. This would be like the first, second, third, fourth, fifth, and then we could generalize it to say the nth place. An arithmetic sequence is a sequence where it adds or subtracts by the same number each time. And whatever they add or subtract, that's called the common difference. So in this one here, where it's 5, 10, 15, 20, we can ignore that k. It's 5 plus 5 is 10, plus 5 is 15, plus 5 is 20. So my common difference d is equal to positive 5 because we add 5 each time. Next up, write the next three terms of this arithmetic sequence. So that has messed up. It is supposed to be -6, -2, and then 2, 6, and that k is supposed to be a dot, dot, dot. I'm not sure why it's messing up. So -6 to -2, well, that would add 4. And then -2 to 2 would add 4. 2 to 6 would add 4. And we're supposed to write the next three terms. So if we add 4 again, we would get to 10. Plus 4 is 14. Plus 4 is 18. So 10, 14, and 18 would be the next three terms of that arithmetic sequence. Next up, let a sub n be the nth term of an arithmetic sequence with a first term a sub 1, right? So that's just saying the first one listed, and the common difference d, just like what we were talking about. The nth term will be, and let me copy this down correctly, the nth term is given by a sub n equals a sub 1 plus n minus 1 d. And I will often rewrite it as a sub n equals a sub 1 plus d times n minus 1. Right. I normally like to put the d in front. So what that lets us do is it lets us take whatever the first term was and whatever the common difference is, and then we can plug in, I don't know, 100 or 1,000, and we could get the 1,000th term out of that sequence really quickly, right? Rather than having to, like in our previous one, add 4, say that in this one, instead of saying the first three terms, they said find the 1,000th term. If we wanted to find the 1,000th term, that would take forever to add 4 each time. We could just plug it into this formula here and get the 1,000th term right away. So example 12. We're going to write the equation for the nth term of this arithmetic sequence and then find the listed term. So this is 25, 16, 7, and this should be a -2, and then dot, dot, dot. So after we find the equation, or we list the equation, we're supposed to find a sub 14, the 14th term. So 25 to 16, what did they do there? Or what did we do there? I think that's -9. Yes. 16 to 7 would be again -9. That would be in -9. So my common difference is -9, right? We subtract 9 each time. My first place term, a sub 1, is 25. So a sub n, plugging into my formula above, would be 25 minus 9 n minus 1. Now that's good, that's our answer, but I want to simplify that a little bit. So I'm going to distribute my 9. I'll have 25 minus 9n plus 9. And that will give me a sub n equals, combining like terms, the 25 and the 9 will give me 34 minus 9n. And that's going to be our equation for the nth term. Now we want to plug in a sub 14. We'll have 34 minus 9 times 14, which should give us negative 92. So the 14th term is negative 92. Alrighty, that's all for this notes. Make sure that you have this example down. This will be useful for the homework. And also make sure that you have this formula. The most important formula would be that one right there. All right, that's all.